Now let me invite the co-chairman of this session, Sri Devendra Kumar Sharma. Sri Devendra Kumar Sharma is presently the chairman of Bakra Bees Management Board, Ministry of Power, Government of India. He is responsible for managing and operation and maintenance of Bakra Dam, Bees Dam and Bees Sutlej link for providing irrigation, drinking water and electricity to the states of Punjab, Haryana, Rajasthan, Himachal Pradesh and Delhi and Union Territory of Chandigarh. Prior to present assignment, Sri Sharma was Managing Director of Himachal Pradesh Power Corporation Limited. He had end-to-end responsibility for development of 22 projects, including construction of 5 major hydroelectric projects. Sri Sharma, in his long distinguished service, has made significant contribution in the field of water resources and energy sectors. Welcome you, sir, for the session. Rapporteur for the session, Sri Vivek Tripathi from Central Water Commission, New Delhi. Welcome you, sir. Over to you, sir. Thank you.
Good afternoon, everybody. Welcome to the first session. Now, at the outset, because we're running 45 minutes late, I'm going to ask everybody to adhere strictly to the time. It's not fair to the other presenters when anybody else goes over their time. The first thing I'm going to do is actually hand over to my co-chair to keep me honest and on time, because I'm giving the first presentation.
Good afternoon. It's going to be a very vibrant session at the same time because we have post-lunch session. See, we have now Dr. Desmond Hartford, Principal Engineering Scientist, BC Hydro. He would talk about risk and uncertainty in dam safety. Over to you, Dr. Desmond.
Good afternoon, everybody. Now, I'm speaking to you as a dam owner, and I'm speaking to you as a dam owner after the Oroville Dam safety incident. And in my role as a dam owner, and particularly my role at BC Hydro, I've got a very important mission, which is to ensure that we've got the right science and that we've got the science right, and to be able to transform that information into understandable form for the decision makers. Now, the Oroville Dam safety incident was a huge wake-up call for dam owners everywhere. And if you haven't read the report on that incident, I strongly recommend that you do, because it turned out that best practices as they were being practiced were not really good enough at all. And in fact, it's important to note that there was a memo on the internet from the Corps of Engineers where they did an investigation to see if their practice would have also missed this particular event. And they expect that they would have missed it as well. Now, the whole thing about best practice in risk assessment for dams is that the whole of the Oroville incident and all of the reasons for the Oroville incident were known in advance. The industry was told in advance, and the industry refused to support the research because they had best practice. Now, I started working on this Oroville Dam type problem as far back as 2004. And one of the questions was, what happens if the spillway doesn't work? And one of the most striking things is a lot of modern day risk analysis lacks detailed mechanics of what's going on. But Dr. Ralph Peck asked where all the judgment gone. Well, the role of judgment and how it should go through risk and uncertainty and dam safety was set out in 2004. But the practice came into being before the book, and the practice hasn't changed. And what we find is the mechanics, the science, has been overwhelmed by judgments. And they're often described in generic terms, like for internal erosion in ICOL Bulletin 164. initiation, continuation, progression, and breach, and there isn't one bit of mechanics in the whole thing. And the other thing that we see lots of is engineering judgments of chance. But chance is a random event. Anybody can guess chance. Judging it is a completely different matter. And then we find out that here's a result, 10 to the minus something suspiciously large per year. In other words, a very small number. And it's these generation of small numbers, and even in the Oroville Dam case, they didn't put the number on it, they just thought it was extremely unlikely, led to that entire mechanism being excluded. And then we find comparisons with so-called safety criteria, and yet those safety criteria, when we really go looking, are not set up in law. So we want to go back to looking at the mechanics of flows, mechanics of structures, mechanics of materials, and a lot of other things, and get away from empirical relationships.
Dr. Desmond? Dr. Desmond?
Okay.
Thank you.
Okay, so one of the most important things we have to realize is that the whole definition of a failure mode as it's embodied in current dam safety practice is different to every other industry. But if we ask ourselves the meaning of the term mode, and we have flight safe mode, we've got modes of transport, we've got modes of fashion, it's a manner in which something occurs. It's a state. It's not a process. So this is a big issue in relation to modern dam safety practice, the meaning of the term failure mode. And here we have Oroville Dam. Is a failure mode a state or a process, or both? Here we have operational mode and failure mode occurring at the same time. There's something wrong at a fundamental level in our definitions. And even ICOLD is confused. If you go to Bulletin 164, they define failure mode in two different ways. Whereas if we go back and look at the detail of the cause-mode-effect relationships that we have in not only dams, but any engineered system, you define the mode at the level at which you're doing your basic analysis, and then you work it up. And I'll go into this in more detail later. But it's been well known for a long time that failure modes analysis has a number of weaknesses. Any type of failure modes analysis has a number of fundamental weaknesses, and the most important one is the analysis doesn't actually reveal anything that you don't know in the first place. You have to bring all of the failure modes into the analysis in the first place. And it's not quick, cheap, and easy. Event-free analysis also has some limitations. And these have been well known since, the late 90s. The important question we have to ask ourselves is how come we never see discussion about the weaknesses of our analysis methods in any conference presentations? That's a serious problem, but there has not been enough critique of methods. And it turns out that the potential failure modes analysis for the Oroville Dam, which was judged by an independent panel to be one of the most systematic they'd ever seen, failed to pick up the issue properly. They identified the possibility and then they eliminated it because they judged it was a low probability. And this judging things having a low probability and eliminating from the analysis is one of the biggest single weaknesses. We have to carry everything through. So this definition of a failure mode as a sequence of events instead of a state is where we can look for the root of the problem for the Oroville Dam incident. And then we have to deal with the problem of the completeness of the analysis because this is a weakness of failure modes analysis. The failure modes analysis suffers from, all of them do, the problem of errors of omission. Errors of omission are things that you leave out. Errors of commission are where you make mistakes in the analysis. And unfortunately, the way contemporary best practice for failure modes analysis goes, you eliminate things of low probability. You deliberately screen them out. Now, the problem we have here, and it's a very serious one, is we have to get back to the fundamental mechanics and we have to understand Are we talking about functional modes or functional failure modes? But if we begin with functions, and I'm going to explain this tomorrow morning, if we begin with functions and functional modes of the system as a whole, rather than starting with failure modes, we would actually pick up a lot more. And another thing that we need to be able to do is develop functional models of how the dam actually works. When was the last time you saw a functional model of how a dam actually works in a paper, whether it's be in a journal or be in a conference, and you don't find them? We need to develop functional models to explain how things work, and then we've got a chance to explain how they won't work. You invert the thinking. Now, I want to go back to this question of the mechanics of at the core. Because if we build fundamental models of how the dam works, then we can build models of in virtual reality and 3D that take into account time effects. One of the most important things that we have to deal with is that dams fail not at the extreme events, but for what we call unusual combinations of usual conditions. And these unusual combinations of usual conditions are things that happen over a period of time. And we cannot pick them up in a traditional event tree analysis. So we have to realize that the risk analysis methods that forms best practice of today was done for failure at the design envelope. It was all designed around sizing of spillways, determining design capacities of dams. That's where it was 25 years ago. Now, I've been working in this field for 25 years, as an owner for 25 years, and when I say I have to make sure that the scientific validity is correct, it's absolutely important, because as the owner, if something goes wrong, I have nowhere to hide. I'm about to go on to my 4th Director of Dam Safety in that period of time. I've got the continuity of knowledge. I've got the target right here when things go wrong. It's me who's the fall guy. Now, I don't have any commercial interest in any of this. I don't have any institutional interest. I don't have any political interest in promoting any type of method. What is expected of me is that I adopt a scientific, skeptical position in relation to whether or not the science is right and whether or not the science is being done right. They are the essence of what I do. And it's something that we need to bring into in dam safety risk analysis, because at the moment, after the Oroville Dam incident, I cannot stress how big a wake-up call this is. And if we find out that certain parts of the industry are saying, don't worry, a couple of modifications to what we do, or this was an isolated event, that's not the way it is. It could happen to anybody. We realized it could happen to anybody. We asked the question in 2004. So there were no surprises, and as I mentioned, the Oroville Dam incident report clearly shows that in the book we captured everything that went wrong at Oroville in the type of way that it went wrong. They're all there. And where I see the future is building models of how the dams work, running them through simulation models because we've got plenty of computing power. Then we can make all sorts of, create all sorts of problems within our model, which will then allow us to find out how the thing will fail. The output of this simulation model will be a very, very large number of possible chains of events by which the dam could have failed. So a very large number. The objective is to find all of them and not screen anything out. Because the problem we have is, as soon as we say something's possible, it's got a probability, and no matter how low the probability is, the 10 to the minus 8 event happens. The problem we then have is that if we've got a very large number of very low probability events, all screened out of our analysis, we should not be surprised if one of them pops up. And this is a problem whether you're prioritizing or not. It's a problem that I live with, it's a problem that I'm working with, but the future of dam safety analysis, we really need to get the definition of a failure mode right. Thank you. Please, I need to call the next speaker. The folders will not disappear during the session, and your name will not fall off them. So please, we must move on. The second presentation, Decision Making Under Uncertainty on Risk-Informed Dam Safety Management, which action goes first, is by Dr. Jessica Castillo and Dr. Adrian Morales Torres from EPRESA in Valencia, in Spain. Please welcome first Dr. Castillo and then Dr. Morales Torres. Thank you.
So then, good afternoon. I'm really happy to stay again in this conference. And I will present, along with my colleague, Dr. Morales, our contribution to this session. And we bring here the key question for any dam safety program in any country, not only in Spain, where we come from, but also for India, is which action should go first when we are planning and defining a set of dam safety measures. So then, I don't know if my presentation is not here, but let's check. Okay. Well, that's the key question. So then, which measures should be undertaken first, ensuring efficiency and equity? We should program and define the optimal sequence of measures. And for that, we have risk analysis tools that are a helpful tool to inform decision-making, to inform our dam safety actions.
Can we stop for a moment because we still haven't got the presentation up on the screen?
Yeah, maybe some of you remind, there was a blackout last year, now. No, not that one. I can do it. No, 1A. 1A. No, that one. The last one. Well, thank you.
Please continue.
Well, so then I was saying that we have the tools for informing decision-making in dam safety. So then these risk analysis tools can provide a better understanding of our dam systems and a better knowledge of how they are performing. So then we can identify risk, we can estimate risk, but combining both main components. First, the probability of failure and what can happen, and second, the consequences downstream. Downstream for the society, for the economy, and for the environment. So then we should combine both and then being able to quantify risk of our systems. But not only for evaluating the current situation, the current performance, it's also important to prioritize investments, to define sequences of measures in the long term, and then go through a better dam safety governance. So then, we have been working not only in our home country, in Spain, but in many other places around the world, applying risk analysis techniques to inform dam safety management. There are examples in Sweden, in Albania, in Latin America, and also here in India for a pilot case for Bhadra Dam in Karnataka. So then these examples show how we can inform asset and portfolio management. This is an example of River Basin Authority in Spain. The Duero River Basin Authority owns 27 large dams. So we collaborated with them to perform risk models for all these dams, estimating risk with tools that we developed and apply for many, many real cases for many different owners. So then we may integrate all the information of the system, then estimating risk, but more important, integrating risk outcomes from the whole portfolio, then being able to define the risk profile for the portfolio scale, for the whole number of dams that the owner has to manage. So these two software tools, one for estimating risk and the other one for combining different scenarios, allows us to plan and to evaluate the impact of different measures. So we are able to estimate the risk profile for the whole portfolio and then see the impact, the effect of different dam safety actions on risk. So we can reduce the portfolio risk profile, and we should do it in an efficient and economic and societal efficient way. So there are different criteria that we can consider. But that's the question that we bring today. It's, okay, now that we have the optimal sequence of measures, how is uncertainty influencing our decisions? So then it's not enough to estimate risk and evaluate risk. We should also include the impact of uncertainty in our decisions. And we will show the two examples. I will describe briefly the first one. The first one is an example of a cascade system of dams, of 3 dams in Albania. This system was analyzed in the framework of a project funded by the World Bank. And it's the key system for hydropower production in the country. They provide 90% of energy. And these 3 dams, we analyzed these 3 dams with a risk model, integrating loads, system response, and consequences from all 3 dams. And then we got the quantification of risk for these 3 infrastructures. But not only the base case, the estimation for the current situation represented by the dots, the 3 dots, but we also included the analysis of the sensitivity analysis, the impact of hydrology loads on our results. It means obtaining the range of the probability of failure shown in the vertical axis if we consider different hydrologic hypotheses. So then it's really important not only to being able to estimate risk, to quantify risk, but also to being able to quantify the impact of uncertainty in our decisions. So my colleague Adrian will go on with the second example.
Okay, thank you, Jessica. So after making this sensitivity analysis, we went one step further to make an uncertainty analysis, or not only estimating how it will change, but also the probability distribution of risk change. So we have made this in this project with the regional government of Extremadura in Spain. We have made a complete quantitative risk analysis of 4 dams, and this year we are doing 3 more dams. And in this case, I will show you the results of one of the concrete dams. We analyze the sliding failure mode in the concrete foundation interface, and with a I will do it. Yeah. So with a physical model of the sliding failure mode, we analyze how the different values of the resistance parameters of the foundation could change the risk results. So we not only obtain a single value of risk, but we obtain how it can change depending on the distribution of the variables that are used within numerical models. And we also analyze this for the base case, but also for the different risk reduction actions that are being implemented or that are are proposed to be implemented in the future. So we know how risk changes and also how uncertainty changes when different risk reduction actions are implemented. After this, we have first, as Jessica has shown, first we focus on how we can inform decision-making based on risk results and obtain prioritization sequences of potential risk reduction sequences. And then we focus on how to deal with epistemic uncertainty and how epistemic uncertainty could change the risk results. So then we put all together to see how epistemic uncertainty is changing the decisions made based on the results. So last year, we have been publishing different papers in scientific journals, scientific index journals, to analyze the relation between epistemic uncertainty and decision making. And if epistemic uncertainty is making us, it could make us to make different decisions based on the risk results. So we can analyze, for instance, if we have more information, it could change the prioritization sequences that we have obtained based on the risk results. So we have different publications. Here I will show you an example. This is the prioritization of 20 risk reduction actions in 4 gravity dams. So we analyze first in the green line, you can see what will be the risk reduction sequence that we recommended based only on the risk results, and then how it could change based on the uncertainty in the resistance parameters of the dam foundation interface for the sliding failure mode. So we can see how far this uncertainty is moving the decisions that we make. So we would like to analyze how this change and if the order of the measures in the prioritization sequence that we have recommended is different when we make this uncertainty analysis. In this case, we had a quite high index of coincidence, which means that the order of the measures, independently of the epistemic uncertainty, will be, in most of the cases, the same. And we also analyze how it will change if we reduce this uncertainty. So we can see that in this case, the index of coincidence is higher because we are reducing the uncertainty of the reductions of the decisions made. So finally, to conclude, I would like to highlight 2 things. First of all, that quantitative risk analysis and risk analysis is always based on modern dam safety programs and standards. It cannot replace emergency management, it cannot replace hydrological studies or physical model of the dam, but it should be based on them. So risk analysis should always be based on this type of analysis and studies. And at the same time, the outcomes of the risk analysis can also help to improve the modern dam safety programs and the analysis and the other documents that are made. And finally, I would like to highlight that this presentation that we have made on how to deal with risk and uncertainty because we want to deal with uncertainty more than fighting against uncertainty, which is one of the main elements of smart governance. So, yeah, that's all.
Thank you. Okay, we now must move on to our next presentation, which is the 2 phases of the Emergency Action Plan for Dams Development and Implementation. And it's being presented by David Gonzalez-Diaz from the Central Project Management Unit of the DRIP project. He's the international expert here in New Delhi.
Good afternoon, everyone. I am the dam break analysis and emergency action plan expert from DRIP project. So it's a real pleasure for me to be here, considering I come from Latin America. So it's a real pleasure to be here. Today I want to discuss with all of you about the 2 phases of the emergency action plan And maybe you are wondering what is that of the two phases. And to explain a little bit more about this, I want to make an analogy with the social media. Nowadays, it's very common the use of Facebook, Instagram, Twitter, right? So we tend to show only the best side of our lives in those social media. We only want to show when we are happy, we only want to show when we success, we only want to show when we are dining a very good dish, but also we tend to hide at the other side of our life. We don't want to show when we are sad, we don't want to show when we fight with our wife, we don't want to show when we have problems at job. Something similar happened with the emergency action plan. There are two phases. There is a nice phase that everyone wants to show. That phase is the written document, okay? So I want to show you the main, for me, the four main components to develop a good emergency action plan. Sorry. There are four main pieces on this puzzle. The first one is the dam safety evaluation. Is that stage when I can identify the potential failure modes, okay? I can understand how my dam works, so I can isolate all the stages in that process, so I can assign all the emergency levels. So the next is the response procedures. When I already am able to make an early detection through the dam safety to the emergency level, I need to know what to do next, right? So I can make this kind of tables when I can, for every stage, every observation, I can assign all the emergency levels and also identify the action that I need to do in that case. This is also related with the supplies and resources that I need for make those actions and response during adverse weather, darkness, etc. Also, we have the responsibilities. When I identify what to do, I also need to identify what are the responsibles. We need to understand that declare an emergency is a very tough decision, but also we need to understand that an early decision, we can maximize the response time. So here the key words are parties and response time. But what is parties? The stakeholders, okay? We need to identify all these stakeholders and then make something like this, the notification flow charts, okay? Finally, maybe my favorite part is the consequence estimation. Is in that stage when through a dam break analysis, I can make so the inundation maps like this. So I am able to identify the flooded areas, the potential flooded areas. I can estimate the depth, velocities, arrival time, very important. With all these parameters, I can come through with a very good evacuation plan. All these elements is that I call the nice phase. Why is that the nice phase? Because with all these elements leads to a bulky document with a very colorful maps in the document, and everyone wants to show this because it's an indicative that the very hard job that has been done, right? But there is another piece that maybe is very hard to hold in this process, okay? Maybe have printed in one of the phases a hard work ahead, and actually it's a hard work that you need to do, but it's a forgotten stage. It's the implementation. It's the stage where I guarantee that all those procedures that I write in the document, I can handle it effectively in the real life. Okay? If you don't believe me that is the most challenge phase in this whole process, I want to show you some numbers here. India have around 5,200 dams. Okay? If from this list we remove all those dams that do not have emergency action plans, we have this. We only left 7% of dams. Okay? Around 400 dams only have emergency action plan right now. But what happens if we remove also those dams, those emergency action plans that needs to be updated? We only left 3% of dams. Okay? And it's supposed this is the nice phase. Okay? What happened with implementation? How much of these dams are actually implemented? But for that, we need to make a zoom here and split this in 50 pieces and take only one. 0.02% of dams in India have an actual implemented. That doesn't mean only one dam, okay, of 5,000. So we can see that definitely is an unbalance between the development and the implementation. But what is the implementation? What are the main pieces of the implementation? Okay? For me, the Emergency Operations Center. Imagine that a dam owner will start and activate an emergency action plan. You think he can do it from his office with a mobile phone and a single LAN number? He cannot do it. He needs all the means necessarily to activate. It generally is an operation center. Also, we need the warning system. Please, here, the most important that I want to say here is remember that a single horn installing the dam is not enough to warn the people downstream, okay? We need a very good warning system, and at least should be installed in the area with less than an hour of warning system, of warning time, sorry. What else? Dissemination, important. This is related with the awareness among the population, okay? We need to sensitize the people about their own risk. We need to educate them on what to do before, during, and after an emergency, and how we can do this through workshops, stakeholders consultations, pamphlet, brochures, etc. Also, we can use the social media, okay? And finally, testing and training, okay? Remember that the emergency action plan, the main objective is maximize the time for those people that is living downstream for the evacuation process, right? So the main question that should naturally arise after you finish a document is say, is my document adequate enough to save the people downstream? So the only way to answer that question is testing the document, okay? We need to make tabletop drills, mock drills. Exist several types of exercise that you can, very simple exercise, a very complex exercise, and the final objective of this is test the emergency action plan, the document, evaluate the decision making of all the lack of budget and resources, lack of coordination between stakeholders, indolence and ignorance. Unfortunately, still exist people that think that the dams doesn't fail, or at least they think that that won't happen to their dams. The normalization of deviance. The normalization of deviance is the gradual...
Please finish up.
1 minute.
Okay, you've had them.
The normalization of deviance is the gradual process through which unacceptable unacceptable practice become acceptable. After repeating the same without any catastrophic result, you continue to do it again and again. Thank you.
We need to move on, and the next presentation is on the safety of EDF large reservoirs, dams during floods. Feedback on new developments by Manuel Atunes Valeri. Thank you.
Thank you very much. So we are speaking about floods and flood management. As an owner, EDF in France is operating several hundreds of power plants, and with a large variety of them. And more important, for floods, we are operating 640 dams, and among which we can say about 40 large dams. And for that, we have half a century of experience of that. So we engaged in 2015 a large return of experience, of feedback, inquiry. So what the main conclusion of this was that we did things quite well, but with some things that could be or should be improved. And the three main ones were the fact that people on dams has always to calculate or estimate the inflow. The inflow is not a measurement generally, it's a calculation. So we found that it was too difficult for them in real time, not accurate enough. And so we decided to try to remove it from the real-time calculation of the gate opening maneuvers. After that, we also had the feeling that we should simplify the regulation law in order to have the same thing to do from the beginning of the flood to the end, and not depending on the period, on the inflow, on the level, and so forth. And the last one was that we found also that the frequency of the maneuvers journey was calculated for the extreme events, for the safety, for the maximum flood. And in fact, for 90 or 95% of the normal floods, we don't need that. At the contrary, we need to have less maneuvers. So we tried to also, without complicating things for the operators and dams, to simplify all that. That way, we engaged in 2016 a new development based on the theory of the linear systems automatics, in order to have an algorithm based upon a level regulation system and not a flow level regulation system. So this algorithm, we called linear trajectory, in fact, is based on the control of the speed of the lake during the flood. So, for example, this line, the black line is the target for the speed of the level, of the water level, depending on the level itself. So it's decreasing up to the set level in order to be stabilized at this set level. And when we calculate that, for example, for this level, we have the target water level variation, which is calculated with the curve. And the algorithm, in fact, will try to correct all the differences of the real situation between the real situation and the target. As an example, in the real life, we had this example on the dam. We can see that the first period is before the first maneuver, so the water level will increase quite freely. And after that, we will follow the trajectory which will lead us to the target level and stabilize the level at this set point. And this independently from the inflow. So the main interest for the operator on dam will be not to have any more calculation to operate. He will only have to read his level and the variation on a double entry table, and he will get directly the variation of the outflow to operate. And this, whatever the situation is. We also, with the same table, it's possible to double the frequency if the outflow is above a certain value, represented at the bottom of the table, or if the speed of the energy of the flood is too strong, and then we will be on the red zone. Then we have to double the frequency of the maneuver with the same table. We can also anticipate the situation with the same graph. For example, for the first security maneuvers, for the testing of the spillways, for example, or for mobilization. We can also calculate the accuracy of the regulation, and then we can justify the set points in regards with the maximum level authorized during the flood. But there are not only security benefits, in fact, safety benefits. We also observe that we can have some generation benefits because we are able to establish or to estimate the risk to have a gate maneuver to operate. And then just before the flood, we can estimate if we have to lower the level or if we can stay with the level we have. So this is quite interesting, and we observed, for example, on several French dams, that we had a gain of 1 or 2% on the operation with that. So at least we can also have a better view of what to do for the flood management with the optimization of several parameters, such as the maximum operating level, such as the speed of for the level, and also we can have several effects, quite sophisticated, but always remaining with a very, very simple methods for the operator on the dam. So the main interest for us was to cope with some sophisticated effects, desired effects, with the most simple way to operate the gates at the dam without any error. So we had the first floods during the January this year, and they were managed fully successfully. So hopefully for us it was quite an interesting feedback. And also, if you're interested in this kind of methodology, we have developed a kind of internet page, and you can put your own settings on this for your own dam, and try to operate with your own methodology and try to compare with what we are proposing with this kind of methodology. So I will remain at your disposal for that. Thank you.
Thank you very much. Moving on to the next speaker, please. Ton Peters from Deltares in the Netherlands, dealing with real-time dam stability monitoring.
I don't see my presentation. Can you please show my presentation? Yeah, there it is. Okay. The name of my presentation is DamSafe project, a pilot project on dam safety and water management in Karnataka. I'm very honored to be here to present this project that I also presented, the plan for this project I presented last year, and I'm glad I'm here to see so many people that I've met also during the last years. I will tell you a little bit about Deltares, which is Deltares is a Dutch research institute with about 800 people employing. We are working worldwide. About 30% of our work is worldwide, and also 70% is in the Netherlands itself. For this international work, we have small offices around the world, in the USA, Brazil, India, Singapore, Indonesia, and in the Middle East, where we connect to our clients and to our stakeholders, and we perform all kinds of projects in the fields of water, subsurface, and infrastructure. I'm going to talk a little bit about the DamSafe project, but first, I assume that not everybody of you knows the Netherlands. Here you see a picture or a map of the Netherlands over here. And what is interesting to know is that the Netherlands is only a small country. I think it's even much smaller than Kerala. And a large part of the country, about a half, is below the sea level. So if we were not to have any flood defense, this part of the country would be regularly flooded. We have the North Sea here, our main sea, and we have big rivers here coming from Germany and France, the European hinterland, and sometimes the water levels in these rivers can be very high. So we have an elaborate flood management system, which is depicted here. We have dams, we have dikes, like over here. We have also moving barriers, like this one and this one. For example, this is the entrance to the port of Rotterdam. It is a moving barrier, so normally it's open, and when it's a high flood risk, so high water level at sea, we will close this to protect ourselves. To tell you a little bit about the project that we are doing here in Karnataka, this is a project to demonstrate a number of innovative technologies that have been developed in the Netherlands initially, have been used also in other countries on dike systems, like in China and the USA, and that we are now for the first time applying to a real dam here in Karnataka. This project is supported by two main stakeholders, the Karnataka Water Resources Department and the Central Water Commission. They have written support letters that made it possible to get the funding from the Dutch government to do this project. Here you see a number of these technologies that we are applying in this project and a number of our partners, because Deltares is leading this project, but we are working with industry because we think that it's good that we have interaction with industry, involve industry. So we have a company called Royal Eikenkamp who is doing the monitoring, so an online monitoring system. We have a company called SkyGeo doing satellite monitoring. We work with Epresas. You just saw the project, the presentation of Adrian and Jessica for the dam safety analysis. And finally, Deltares is bringing in integrating software, so a platform that integrates all this data and forecasts all kinds of water levels and possibilities of failure. Just two pictures of the Badra Dam. We visited the dam last year. Here's the main dam with 4 spillways, and the dam also consists of 2 embankment dams with revetment. So after the inception meeting and the nice discussions we had at the local office in Shimoga, we started working on a monitoring plan, and you see here the result of that. So what we want to do is we want to monitor, and what we already have implemented this year, or last year, we have installing all kinds of surface level measurement systems in the reservoir itself, and also weather stations in the catchment area to determine how much water it's raining and how much water is flowing into the reservoir. The other type of measurements we are doing is in the dams itself. So for example, here we have drilled holes beneath the dam, in the dam foundation, and installed water pressure sensors. And also we have a system that will measure the outflow, the discharge of water from the drainage system. Similar setups were made here and here, where we have the 2 saddle dams. So now I'm going to tell you a little bit about the monitoring system. So one of the systems is this one, is a satellite-based radar system. So this satellite will pass over India like every 3 weeks in average. It transmits radar signals that bounce back from the Earth's surface. And this satellite will continue to fly by the next time after 3 weeks, etc., etc. And when you collect a data set of about 20 to 25 images, you can use data processing technology to determine the persistent scatterers that you see in each image. And that will allow you to detect very accurately the deformation of the Earth's surface. And we are talking about a precision at millimeter level. And that's what it makes it interesting for civil engineering purposes, because that can be an indication that something is happening with your dam. So the deformation is the key measurement parameter that we are talking about. These satellite images are big, like 30 by 50 kilometers. So you have, in one go, you have a lot of information of the whole area. So also, when there are more dams in that area, you get all these results. Just to give you an example, I couldn't show it now, but I can show you later if you pass by the real online system, because this is just an internet portal where we can just log in and have a look at the data. So I can demonstrate it if you want. So here we see the Badra main dam, and each dot represents a measurement point. So this is about a period of September 2016 to December 2017, and that accurately displays, you see the displacement in millimeters per year. So you can see over here that there is not a lot of displacement, which is a good sign, of course. So you can conclude that from this measurement, you do not anticipate any big problems. The similar we did for the Kabini Dam, but I'm going to skip that and go to the last part. That is the DelftFuse integrating platform. So we have all the measurements, the data that is integrated into Fuse, and we can run models in an operational system. So it will go automatically, and then we will export the data for dissemination and for viewing. So here you see what's integrated. So the measurements of Agricom, SkyGeo. This is the global forecasting system. So that's weather forecasting. And we link that up in the Fuse system with all kinds of models. So we have, for example, the HMS hydrological model, but we also have our own hydraulic model in SOBEC, and we have the dam safety, dam stability analysis models. So routinely we will do these calculations, and you get an answer immediately. That's the idea behind it. Also, you can use this for forecasting. So this is just an overview of the visualization of data. For example, here you see the water level at the main dam. Here you see the water pressure beneath the main dam, so in the dam foundation. And here you see again the PS INSAR deformation measurement. So this is the the viewing of the information, of the data. We also use it for forecasting, so this is reservoir forecasting. What you see here is a number of moments in time when you do a forecast of your water in your reservoir. So this is depending on rainfall, of course, runoff, the water level in your river, and then you do a forecast at this time, and you do it at the next time and the next time, and that will allow you to get accurate forecasting of your water levels in your reservoir. We also use this for online direct analysis of the stability of the dam. So we have, like for the main dam, we have installed pressure sensors in the dam foundation. We are not so far in the project yet that we have connected the real data to this failure model calculation. So we have made an assumption just to you to show what the results would look like. And we assumed a head rise of about 12 meters below the dam, and then we can calculate a safety factor that is going down from 3.75 to 2.25. So you still know that you're in the safe side, and that's one of the advantages. So if you are in a situation when there's a lot of water in your reservoir, you measure a lot of water pressure in your dam, you can then have immediately a result of the calculation of stability. The same is done for the stability of the macro stability of the saddle dams. It's a similar setup, but it's a completely different model that we use here. To conclude, we have now designed in this project, and installed an in-situ monitoring system, and we have about 1.5 years of dam deformation measurements. And for the future, for the coming year, we will complete this Delft-Diffuse system, and also for training purposes and for interaction with the Karnataka Water Resources Department. 2 of the engineers will come to the Netherlands for a longer period of time to work with us. Thank you for your attention.
Thank you, Tom. Now we must move on quickly because we've only got 10 minutes left to the presentation on CFD modeling of piano key weirs using Flow 3D by Amir Isfahani from Flow Science Incorporated in Santa Fe, New Mexico.
Thank you very much. It's my pleasure to be here. Before I start, I just, as a CFD solution provider, I would like to share with you some of the trends that we have been observing. We are in a fortunate position of being in the intersection of this industry and see most of you and companies like you and governmental agencies like you in action, what they do, what they're using, and what the trends in the industry are. Again, as CFD solution providers, we see dam owners like BC Hydro, large water consultants, AECOM, Golder, the big guys, federal and local governments, CWPRS here, USBR in the US, and US Army Corps of Engineers, start to shift to use and require the use of CFD on top of physical modeling. Of course, you can't move away from physical modeling, but where you can do 4 or 5 iterations with physical modeling, you can do tens, if not hundreds of iterations with CFD. Most of you are familiar with 1D and 2D models, but full-fledged 3D modeling is becoming more and more prevalent, and it's much more accurate, and the level of details you can see in these models is what makes them accurate, makes them very attractive to the industry. And computational power these days is available and relatively cheap. My talk is very simple for the level of an esteemed audience like yourself, but its simplicity at the same time is quite powerful. I have 3 animations in my presentation that hopefully will whet your appetite for more 3D modeling. And this is demonstrably very powerful and important when it comes to dams. doing modeling of the dam in its full glory, three-dimensionally, is getting more and more important and attractive these days. So without further ado, I have the privilege of being here. Of course, two of my top-notch hydraulics engineers have done this study, and it's the validation and analysis of a numerical parameter space when it comes to piano key weirs. These types of weirs are now becoming very popular in Asia, and North Americans are also following suit. So we'll look at the motivation behind this study, some experimental setup that was published, and we took that setup, and we do this quite often on a weekly basis. Validate and do sanity checks on the CFD solution and make sure that we are producing what actually happens in reality. So we'll go over the CFD model and do some sensitivity analysis on various parameters and hopefully build some confidence in doing more CFD. Flow3D is widely used for spillway discharge analysis in North America. It's my pleasure to say that we are becoming the industry standard. If you go to USSD, ASDSO, CDA, these are all dam conferences, major dam conferences in North America, and you see papers left and right done with CFD and more specifically with Flow3D. And there are advantages to Flow3D that I don't have time to talk about here. We do have a stall number 1 that you can stop by and ask more questions and see more of this with us there. So we have a long history within the water civil infrastructure engineering for more than 20 years. This is a Los Alamos National Lab technology that we took and commercialized 37 years ago. It's well validated for OG and many other open crest configurations. And here I have an example that I can show you for a simple OG weir, and you can see the full 3D dynamics of the flow and the discharge. Now this is quite simple. When you compare that with labyrinth or piano key weirs, then the geometry and the flows are quite a bit more complex. And here I have an example of a labyrinth weir. And you can see that the dynamics of the flow is much more complicated, and you have all kinds of naps and complex flow features that you can't see with 2D or 1D modeling. And these are important. If you want to see what happens on the embankments, if you have sedimentation, scour, and deposition, you have to do this in 3D. So let's go over the lab environment. This study was published by Ricky Anderson at Utah State University, and it was right up our alley. So we took that thesis, we kind of dissected the geometry, and here is the experimental condition, and we're not going to go through the details of it because I'm going to show you the results and how closely CFD comes to physical model. So some of the results from the thesis, the red line is a theoretical analysis of the discharge, and then the symbols and the black lines are the experiment itself. These are for PK weirs with different inlet to outlet ratios, and we picked one of those again and ran with it. This is how it looks like in action in the lab. You can see the free surface of the water and its profile for type A and type B piano key weirs, and they're just slightly different in their definition of geometry. Okay, so we have the physical geometry. We will go CAD it up. You load it into the software. It's quite simple to use. And now let's look at the CFD environment. You have some tricks available to you when you do CFD that you don't in a physical model. For example, we are taking advantage of the symmetry of this piano key weir and just will do a section, a symmetrical section of the weir itself. Of course, we verified and made sure that that section comes within, in this case, 2% of if you did the full dam at full scale. Okay, so we mesh up our geometry and play with the mesh resolution. The minimum requirement for mesh resolution, of course, is for you to resolve the geometry. And any finer you go beyond that is to resolve more and more of the flow features. And you can make the best judgment. You are the expert of your particular setup, and you can make the judgment of when to stop adding resolution and complexity to your CFD model. Because at some point, the computational work gets prohibitive and you can't run those many, many iterations. If each iteration takes 3 or 4 days to run, then you're limiting yourself in the number of iterations and analyses that you can run. Okay, so different mesh resolutions across the NAB looks like this, and we will see how these perform compared to the physical model. Okay, so 4 to 8 cells across the NAB, that's our kind of location, the most sensitive location that we have to make sure we have enough cells. We use different turbulence modeling with different parameters that you have access to in the software, different controls over the pressure solver and its convergence, and different advection schemes. If you're familiar with the numerical algorithms and computational physics, these are very standard things to vary and get a good convergence from the CFD model. Here's the results, and here's the dam in its full 3D glory. And you can see things that you can't see in 2D. Okay, so some discharge results. Blue lines are the physical experiment, and you can see that the red dots that come from Flow3D are dead on. Here's the parameter space that we swept, and the important column to focus on is right here. Your errors are anywhere from 1.3% to worst case scenario, 9%. And we have done something foolish there, that we are getting a 9% error. You can safely stay under 4% with very reasonable resolution and very reasonable runtimes. Okay, obviously, if you increase your resolution, your percent error decreases as expected. But again, you decide whether you want to go this fine or not. Sometimes this is just good enough for the type of study that you're doing. One thing you have to be careful about is also the physical model has some uncertainty built into it. And there is no point in going below that level of uncertainty in the CFD model. Okay, good agreement, fairly robust. As long as the first order is used, discharge error is under 4%. Scheme order and meshing are most important. The mesh resolution needs to be sufficient to resolve critical flow features. In this case was the NAP. And finally, my 9 seconds, I'm going to use a word of caution. What you did here and the parameters you used for this particular type of flow does not automatically transfer to other types of flow. If you have vortices, you're going to need a different numerical scheme to preserve all the energy in the system. If you go with a first order that was appropriate for this PK weir, that's too dissipative and you won't get your vortex for rotational flows. So you have to be careful and play with these different parameters. Of course, if you come from a CFD background, you know what to use. You have an intuition of what to use for these various types of problems. With that, I thank you for your attention.
Thank you very much. Now, I'm afraid we are already into the time allotted for the next session, which is starting 2 minutes ago in this room. So I'm going to quickly ask my colleagues on the panel to sum up their thoughts in the session. With regard to questions that you might have for all of the presenters, you know what we all look like. We're not going anywhere. This is a wonderful place to be. So you can ask us questions anytime in the next 24 or so hours. So please feel free to come up to anybody who you want to ask a question to, after the session or this evening or tomorrow. But to pass over now to my Vice Chairman to sum up his thoughts on the session.
Thank you, Chairman. So we had wonderful presentations in this session. There were in total 6 papers. Out of 6, 4 papers dealt directly with the risk analysis, and remaining two papers, one paper dealt with the real-time stability monitoring, and the last one with CFD modeling of piano KVR. Well, when it came to the decision making, we saw wonderful presentation by the chairman, Dr. Desmond Hartford. Then he talked about the functional modes and the functional failures. We had the second paper on decision making, wherein different dams, 4 dams in Albania and a dam in Spain were discussed, and the importance of simulations in modern dam safety program to risk-informed dam safety management was discussed. It was another wonderful presentation. Then we had the number 3 presentation about the emergency action plan, wherein we talked about the 2 phases, and also he gave a presentation about the where dam safety emergency plans. There are a percentage of 7% dams in India have dam emergency action plan, and only in 0.02% it's being implemented, which is cause of concern for all of us. We had presentation from EDF on large reservoirs, which was another linear trajectory algorithm. It was a beautiful paper. Then we talked about, the next paper was about real-time dam stability monitoring. Yes, INSAR is a tool. Well, we need to develop it a little further, because once we have a confidence into the entire system, maybe it would be quite useful for the earth-come rockfill dams or earthen dams. Last paper, as you know, it was about the CFD modeling of piano KVRs. The last paper talked about 4% error into the actual and this, which is quite good, and maybe slowly with 3D flow system we can get into the physical modeling transformed into numerical modeling. With that, I hand it over to the chairman.
And if we could have some final comments from our reporter, Mr. Tripathi, please. Okay, that's the session finished. Are we going to have a group photograph? Okay.
Let us have a photograph of the speakers. Please come to the dais. Please, it is requested. Thank you. Now, as a token of our respect and appreciation, we would like to present a memento to the delegates who presented their paper in this session. Let me request Dr. Desmond Hartford to present the memento to Dr. Adrian Morales. Please receive the same. May I request Sri David Gonzalez Dias to receive the token of appreciation from Dr. Desmond Hartford. Let me invite Sri Manuel Antunes Valari to receive the memento from Dr. Desmond Hartford. May I invite Sri Tone Peters to receive the memento from Dr. Desmond Hartford. May I invite Sri Amir Isfahani to receive the memento from Desmond Hartford. Let me invite Sri D.K. Sharma to receive the memento from Dr. Desmond Hartford. And it is requested, please receive the memento Sri Vivek Tripathi from Dr. Desmond Hartford. Let me now invite Sri D.K. Sharma to present the token of appreciation to Dr. Desmond Hartford for being the chairman of this technical session and for the theme paper. Thank you all. Thank you. Now we come to the end of this technical session, Uncertainties and Risk Management in Dams. Thank you. Please be here. Excuse me, please. Sri Vivek Tripathi to receiving the token of appreciation. Thank you, sir. Thank you. Now, please be here within half an hour. Technical session is over now. Thank you.
Hi, the time is getting short. Would everybody kindly take a seat and let's start the last session of the day.
Hello, may I have your attention please? Please assemble for the next session. I have a few announcements to make. One is immediately after this session, we'll be going to Hotel Uday Samudra for a cultural program and banquet dinner. The cultural program will start at 6:30 and transport has been arranged for you. So this is one thing. And for the banquet dinner, the food coupons have been given to you and then you may have to present it while taking the food, this one. Now, may I request the Mr. Samir Shukla? Yes. Mr. Bernard?
Can we start?
Yes.
Okay, good afternoon. Let's start the last session, the industry session. Just quickly introduce myself and give to the other co-chairpersons also. My name is Jun Matsumoto. I'm from the World Bank office in Jakarta, Indonesia. I just moved about a couple months ago. Prior to that, I was a part of this dam rehabilitation family here for 4 years and have worked together for the dam rehabilitation project to come to this stage. And I look forward to meeting you all.
Hello, Bernard Valui, Head of Group Operations at Alpic, Switzerland, Lausanne. I have a background in civil engineering and I'm in charge of the ISO 55000 certification in asset management for Alpic and all the risk and condition-based maintenance of all our equipments.
Hello, myself Samir Shukla. I am Director in Central Water Commission, mainly dealing with the design of barrages and canals.
Okay, thank you. We have an ambitious program of introducing 12 industries representatives. So if each of the presentation people, if you could limit to 5, maximum of 6 minutes. I know it's kind of rushy, but let us try to do so, okay? With that, can we have the first presentation from the Trimble, Mr. Munish Malhotra.
Good evening, everyone. Well, we are still people pouring in, so it's time to start because we have very limited time and we really need to conclude the day today just to rush for our dinner. Okay, so thank you organizers for giving us an opportunity to be here. We are very glad and be a part of the DRIP program. And we really look forward for bigger association with the DRIP organization. So today, since the time is very limited, I'll just have an introduction to Trimble in a very small video, which is as a message can give us what Trimble does and how we can really help the industry today. Today, Trimble is involved in dam monitoring projects across the globe and in the region. We are doing one of a very large project called Victoria project in Sri Lanka, Victoria Dam, for a real-time monitoring. So that project is undergoing and we'll have that results in a 3 to 6 months time where we have all the results with this. Once again, I'll not take much of the time. I'll just start the video and that should give the message clear. So after that, if you have any question answer, we are ready to take that, please.
It's never been easy to manage the power of nature, whether it's due to tsunamis or earthquakes, landslides, volcanic activity, or man-made issues. Real-time monitoring is essential, from monitoring the structural integrity of the most vulnerable support areas of our bridges, to ensuring the wall integrity of steep slopes of earth and mining structures, from searching for strain on dams and landslide detection within dam retaining areas, to calculating the effect of tunneling construction on the structures nearby and above. Effective real-time monitoring is essential to protecting buildings, hillsides, urban infrastructure, and of course, the people who live and work near them. But monitoring today's world is challenging. Architecture and infrastructures are increasingly complex, and regulatory requirements are increasing. In seismically active areas, developers and contractors need robust, accurate, real-time data to mitigate the impact of disasters and confirm that their assets are safe. And departments of transportation and urban planning groups are also hungry for monitoring data. That's why a growing number of asset owners and operators are turning to Trimble for their real-time monitoring solution needs. All across the world, Trimble monitoring equipment and software are on the job. The systems are gathering and analyzing data on hundreds of construction sites and are doing so with remarkable precision, 24 hours a day, every day, year after year. Highly precise Trimble monitoring solutions include sensors that can be monitored and controlled remotely from the office and moved when they need to move to monitor different stages of a project. Trimble's powerful software delivers data in real time, enabling rapid decisions while reducing costs and risks. So any time of the day or night, you're ready the minute there's a problem. Trimble systems are also monitoring the uncontrollable activities that can affect the stability of natural structures. From scientific research to hazard mitigation applications, Trimble has robust seismic and earthquake solutions to deliver the visual data and analysis you need to make the right decisions at the right time. Trimble monitoring systems also play a vital role in protecting buildings and other man-made structures. Trimble's precise monitoring sensors detect trouble and deliver the specifics and analysis you need to take action when unexpected challenges occur. The systems are always on the job, always ready to alert you wherever you are, whatever happens. At the heart of every Trimble monitoring solution is unrivaled software. Robust and powerful Trimble 4D control monitoring software offers a high level of compatibility, even as it delivers unparalleled details and information, with complete sensor management that enables you to customize and add instruments, sensors, and functionality as your project needs to change and expand, and with tools to create visual results for rigorous analysis and alerting. Trimble 4D can handle the challenge of complex monitoring projects, giving you peace of mind. So whatever your role in this unpredictable, vulnerable, fast-changing world, rely on the one company that offers scalable, adaptable solutions that meet any monitoring challenge. All Trimble products and systems are backed by unparalleled service and support, with over 16 factory support and service locations and over 100 authorized repair centers worldwide. And with over 2,000 distribution partners globally, you're never far away from the support you need, wherever you are. Turn to Trimble and Trimble Monitoring Solutions.
Thank you very much for your patience. I think we are able to give the message that Trimble is there for a real-time monitoring of your dams. So any anomalies that we can detect, we are here to find out and giving you the real-time data on your mobiles and handsets wherever you are across the globe. Thank you very much. For any queries, we are here on the booth outside. Please come visit our booth and we'll be able to resolve all your queries. Thank you very much. Thanks a lot.
Thank you, Manish. Thank you so much.
I think I'm on time.
Hello?
Let's move on. Our next presentation is from the company Ferro Concrete. Instead of Mahavir, we have Anupam, who will be presenting from the firm. Anupam, please go ahead.
സുഹൃത്തുക്കളെ, ഒരു അനൗൺസ്മെൻ്റ് ആണ്. ഈ കൈവശമുള്ള ഫോൾഡറുകൾ ദയവായി ഒന്ന് പരിശോധിക്കുക. ഏതെങ്കിലും മൊബൈൽ ലഭിക്കുകയാണെങ്കിൽ ഹാളിൻ്റെ മുൻപിലുള്ള റിസപ്ഷൻ കൗണ്ടറിൽ ഏൽപ്പിക്കുക. Ladies and gentlemen, please check your folder. Certain folders are misplaced wherein some mobile phones are placed. If found, please return the same to the reception counter.
Can I start?
I hope that was not a part of your presentation. Maybe we can restart that, okay? Thank you.
Respected Chairman, sir, Mr. June, Co-Chair, sir, Mr. Alberto, and Reporter, sir, Mr. Samir, ladies and gentlemen, good evening. I am Anupam Vidasaria this side. I am here to give a brief presentation on our organization, Messrs. Ferro Concrete Construction India Private Limited. Ferro is a specialized construction company which is having an experience of more than 5 decades and has worked on more than 300 projects across India. Ferro is one of the leading execution agency under the current DRIP program. The company is managed by a group of professionals who are well renowned in their spheres of specialization. The company is currently headed by Dr. Mahavir Vidasaria, who is a renowned figure in the area of dam rehabilitation, foundation treatments, and is considered as an expert on many other geotechnical issues. He was the president of the Indian Geotechnical Society for the 2 consecutive terms. This is what we do. We are into construction of new dams, rehabilitation of old dams, where we are doing upstream treatments, polyurethane grouting, cement grouting, almost every kind of treatment we are doing in rehabilitation field. Then strengthening of foundation by drilling and grouting. We are into diaphragm walls, piling, sheet piling. We are doing rock and soil anchors, designing foundations and ground improvements. And we are into construction of bridges and industrial complexes also. This being a most prestigious platform in the area of dam safety, I would like to give you a brief overview of the projects we are currently undertaking in area of dam rehabilitation. The first and foremost among them is the famous Krishnaraj Sagar. This is the bird's eye view of the Krishnaraj Sagar Dam. This famous masonry dam, 2-kilometer long masonry dam, was constructed under the guidance of Sir Vishwesaraya, the father of Indian civil engineering. It is a 100-year-old dam and was showing signs of distress, hence taken up for rehabilitation under the DRIP program. Here are some of the photographs showing the seepage on the downstream of KR Sagar Dam. Here you can see the seepage. The main items executed in rehabilitation of KR Sagar Dam is repair of large cavities by mortar filling, horizontal grouting of the upstream face, wrecking of the old worn-out pointing, repointing with fiber reinforced high-strength mortar, and drilling and consolidation grouting of the dam body. Here is the upstream pointing in progress, which is being done with the use of access platforms lowered from the dam top. Around 40,000 square meters of pointing have been executed in a period of 10 months. This is the work of diamond drilling in progress from the dam top. This is the work of grouting in progress, which is being done with use of cement and non-shrink admixtures. This is the second project, that is the Narayanpur Dam on River Krishna. Here is some photographs of the dam before the rehabilitation started. This is the condition of Ogi. The main items executed are repair of cavities by micro-concrete, polyurethane injection grouting to plug leakage of spillways, treatment of second stage honeycombed concrete in the pier region, and abrasive resistant coating on the Ogi surface. This is the work of micro-concrete in progress. Here you can see the application of bond coat has been done, in which the micro-concrete is laid. There's a few photographs of micro-concrete works in progress at Bhadra Dam. This is the work of polyurethane grouting, which is being done by use of 2-component hydrophobic foam to arrest the seepage through in the spillway. This is the work of the same polyurethane grouting in progress. This is the preparation works for the abrasive coating in progress. This is the cleaning of the OGI surface being done. This is the cleaning of OGI being done with the use of air and water jet. This is the application of the abrasive coat in progress, which is done by use of air pressure and a special worm machine. This is the repair of the second stage concrete on honeycombed concrete in the pier region. This is the raking of the old concrete, the loose concrete. This is the application of the bond coat in progress. Then this is the repair of the damaged area. This is the famous Almaty Dam. Almaty Dam is one of the largest reservoirs in southern India. This is the seepage on the downstream. This is the condition before the rehabilitation started in the upstream. Due to shortage of time, I won't go much in details. These are the items executed at Almaty Dam. This is the upstream treatment in progress. This is the drilling from the dam top. The grouting is being done by use of cement along with microfine silica and crystalline admixtures. This is the Bhadra Dam near Shimoga. This is some photographs of the seepage on Bhadra Dam. These are the items executed at Bhadra Dam. This is the work of horizontal grouting with the use of microfine cement that is in progress at Bhadra Dam. This here you see there was a porous hole in the gallery from which there was a heavy seepage. So this was systematically planned and plugged with the use of cement grouting. Now this is the condition, there's no seepage from that porous hole now. This is the work of polyurethane grouting in progress on the spillway. This was the condition of the OGI before the rehabilitation started. Now it is being resurfaced with the use of micro-concrete. This is the present works in progress at Bhadra Dam. The work of ferro-concrete has been recognized at various forums. Recently,
can you wrap up?
I'll take a minute. So, the rehabilitation for Krishnaraj Sagar Dam was bestowed with Award of Excellence for the year 2017. This is the award that Almaty Dam received for rehabilitation in the year 2016. The company is a member of Committee for Review of Indian Standards on Grouting, 5 Indian Standards on Grouting. The company has also been nominated as a member on the panel of experts for review of rehabilitation of Temgad Dam. Sir, thank you so much, sir.
Thank you very much, Anupam. This was from Ferro Concrete. Nice to see some of the real activities from the dam rehabilitation project here in India. Our third presentation is from Capri, India. The presentation from Mr. Alberto Sucuero. Oh, he's been replaced? I'm sorry.
Respected Chairman, Co-Chairman, Reporter, ladies and gentlemen, very good evening. Unfortunately, Mr. Alberto could not attend it due to some reason. So myself, Pankaj Roy, will present the industrial presentation on behalf of Carpi. So Carpi is into construction and maintenance of hydraulic structures. Carpi is specialized in waterproofing contractors since 1963. Carpi is into design, supply, and installation of geomembrane systems for all types of hydraulic structures, underground structures, and environmental protection structure using synthetic watertight geomembranes. So Carpi provides the design, material, as well as install the entire system. So Carpi Group, established in the year 1963, has been pioneered new installation technologies that are now patented system used worldwide for rehabilitation and new construction. and continuously introducing new technologies and solution of higher performance to the global market. Who we are. Carpi has the longest and largest record in the world for geomembrane installation in hydraulic structures. With geomembrane system, we have done more than 150 large dams, more than 50 canals, and hydraulic tunnels, and more than 30 reservoirs. We have the presence across the globe. We have completed more than 1,300 projects worldwide in all the climatic conditions, either it is in hot or in low temperatures. So, Carpi geomembrane used with the trademark of Civilian Mat. Since last 40 years it is performing. Carpi supplies the necessary equipments, labors for the installation in the dry as well as in underwater in any depth or any environmental condition. We do the turnkey projects for all types of dams, gravity, buttress, arch, multiple arches dam, roller compacted dam, embankment dam, and coffer dam as well. We do for the pump storage, reservoirs, water storage basins, floating covers, free flow canals and hydraulic canals, pressure tunnels and shafts, water supply and sewage treatment, civil works, foundations and roofings, railway, highway, and motorways tunnels. We do underground structures, search chambers, SS shafts for the power plants, portable water storage structures, floating covers to avoid air pollution and liquid evaporation, synthetic diaphragm against pollutants. So we have the range of applications for concrete dam, RCC dam, embankment dam, canals underwater, and reservoirs. We also have the system for hydraulic tunnels, shafts, then external water stop, then we have the containment, floating covers, water storage structures. So we take care of the rehabilitation of concrete dams. Carpi civilian mud geomembrane stops water infiltration and gives freeze throw protection also. We take care of embankment dams rehabilitation. So civilian geomembrane provides water tightness even in case of large settlement and seismicity. Carpi takes care of RCC dam for the new construction as well. We have the drain geomembrane system that bridges the cold and lip joints and reduces the upliftment. Carpi provides the solution for embankment dams, tailing dams, and coffer dam for new construction as well. Carpi geomembrane system provides water tightness even in cases of large settlement and seismicity. We provide solution for reservoirs and pump storage for new construction as well as old construction also. So this geomembrane stops leakage, evaporation, and contamination. Carpi has systems for repairing canals and laying of geomembrane for the new canals also. So these are the few of the systems where we can see the Carpi system can bridge the joints and cracks and increase the flow of water in the canal. Carpi has developed a new system that is called underwater installation for flowing water, the civilian mud system. We can install the civilian system without stopping the flow of water in the canal. So this is one of the project, Ismailia project in Egypt, where the installation work is going on without stopping the flow of water of the canal. Carpi also undertake the installation of geomembrane for underwater structures like dams. So you can see the effectiveness before and after the installation of geomembrane on the underwater structures. So we can install, and it does not affect the operation and the environment also. Carpi system has the external waterproofing water stop systems that provides the water stop externally, in the dry condition as well as in the underwater condition also. Carpi system has a solution for hydraulic tunnels and shafts. This Carpi Sibilant geomembrane stops seepages, increases flow of water, and minimizes maintenance in the flowing canal and pressure tunnel. Also, we undertake waterproofing system for traffic tunnel and underground structures. So Carpi has its design, research, and development team. Carpi's material and systems have been extensively researched by Technical University of Munich, US Corps of Engineers, Research Institute of Hydro-Quebec.
Sir, can you wrap up, please, slowly?
So, for any further detailing or any queries, please visit our stall. It is at 27 only. And you can also log on to www.carpitech.com for further details. Thank you. Thank you so much.
Thank you very much. Let us continue. The next firm is Apar Infratech. Mr. Suresh Nair. I'm sorry. If you could introduce yourself, I did not have your name here. Yeah.
Up and down. This is hello, 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 hello. Good evening, everybody. Myself, PK Singh from Apar Infratech. Apar is in operation since 2001, and Apar is ISO 9001 in 2008 certified. Apar Pan India presence. It is a specialized civil agency for rehabilitation and improvement of hydro projects, concrete and machineries. I go through some project which we have done from 2009 to 2017. This is the project meant to do Laskar. Here the water is acidic, that's why some concentrate is used for reduce the acidic nature of the water. This is another dam, Nathpa Jhakri. We have repaired the piers of this dam. This is the situation when we take the work. First we go through the sample, then they approve after next year. This is work in NHPC Chamera 3rd. This is LEZ and Sursaft. This is NHPC Uri. This is NHPC Dhauliganga in Uttarakhand. This is NHPC, Parvati, HRT work. It is leakage from some point. This is Chamera third project. There is leakage, water losses, 7,000 LPS. Uh, 28 Jan 2007, the water losses is 7,000 LPS. After on 4 April 2017, 7 LPS. The problem of eroded spillway basin of Nathpa Jhakri. This is the Asan Barrage. Problem with power channels. The product used in this work, patch and plug and Megamix 2.
VK Singh, can you slowly wrap up, please?
Thank you, your valuable time. Thanks.
Now the floor goes to Mechatronics, Mr. Ashok Karwa.
Good evening. Thank you very much, the organizer, for giving me the opportunity to present myself and my company before you. I'm from Mechatronics, where in the real-time data acquisition, flood forecasting, flood management, dam automation, canal automation, smart irrigation, smart city water supply. Mechatronics is the company established in 1991, having the certification of CMMI level 3 for the software development. We have the software development team for the water resource management that includes the flood forecasting, flood management, real-time data acquisition, SCADA, GIS, and ERP solutions for the water resources. Then we have the ISO 2007, 27001, 14000, and 9001. This is the only company in India which is a truly indigenous and having the in-house develop the complete solution for the water resource management. Recently, we have received the CBIP award for the best innovative solution for the integrated water resource management in the water sector. We have the presence all over India, pan-India. Our business areas are the real-time hydrometeorological information system, flood forecasting, early flood warning, flood management and the reservoir or dam automation, canal automation, GIS-based smart irrigation management system, smart city water supply, geographical information system, enterprise management information system for the e-governance, telemetry systems, and the smartphone applications. Now the irrigation is having the challenges for monitoring the water resources because of the burgeoning population and the erratic behavior of the atmosphere. And they have to take many difficult decisions during the flood and drought conditions. So unless they have the real-time data from the field, they cannot take the appropriate decisions in time. Now the present scenario of the operation is the totally manual operations, knowing the rainfall data manually, river gauging, water supplies, canal monitoring, everything, and even the spillway gates are operated manually. And there is a human intervention which causes the errors and may cause in the disaster. Now even our Honorable Prime Minister also having the vision that there should be a digital India, smart India. So it should be farmer focus or the stakeholder focus solution for the water resource management. That we are going ahead with the GIS-based smart irrigation management system. Way forward making information technology in the digital world, adopting the ICT and the digital technology, thinking beyond the dams, reservoirs, welcoming the new approaches, adopting the new style of the management, encompassing the wide variety of the management and tools. The solution is the GIS-based enterprise management information solutions, smart weather, rainfall, flow measurement, dam and canal automation system, judicious equitable water distribution through the smart irrigation water supply, IT weather communication systems, soil health surveys and soil health cards, farmer information kiosks and farmer applications on the smartphones. We have the complete solution having the hydrometeorological information system, real-time forecasting, canal automation, smart city, validated application, enterprise management and GIS which has been interfaced to each other, and the solutions is working in the water resource management in various states. How the softwares and the solutions are being interfaced to each other. You can see the GIS-based platform on was the MIS and the SCADA is interface. These are our verticals. When we are coming for the dam safety, how the reservoir can be operated safely without affecting the safety of the dam. And so that is depending on the inflow forecasting, how much water we can store in the reservoir, how it can be released on the downstream without affecting the downstream areas. And for that, we have the solution that the real-time hydrometeorological data acquisition, real-time inflow forecasting, flood forecasting, then discharge management and the reservoir operation based on that inflow forecasted. This is how the system for the flood monitoring and flood forecasting. We have all type of communication medias like VSAT, UHF, INSAT, GSM, GPRS. This is the canal management system which is working in Karnataka as well as in Rajasthan. This is the farmer information kiosk which farmer send their requirement and the water is released through the canal as and when they require. So the judicious and equitable use of water and distribution of water. Then the smart city water supply schemes. Then enterprise information management system for the e-governors of the department, water resources, where all the information regarding their resources, their projects and everything on fingertips. We have about 45 modules on this. Then geographic information, satellite imagery, crop pattern analysis, soil health, land use and land cover, water resource association and farmer information kiosks, base map creations. Then there are number of mobile apps for the water management, flood forecasting, flood management.
Mr. Ashok,
And these are some success stories
please
which we
wrap
have
up.
completed.
Still have.
Yeah. Just these are our in-house developed product, that is a SCADA software for the water resource automation, like a dam automation, canal automation, water supply scheme automation, farmer information kiosks, and then AIMS software. Then this is the fully integrated automated canal gates made in stainless steel, having the inbuilt capability of flow measurement, level measurement, communication, solar powered, mobile apps, our data collection platforms, canal discharge measurements, automated rainfall stations, full climate stations, river water level discharge and discharge stations, then gauge actuators, gate measurement systems, and these are some appreciation and encouragement from the dignitaries. Thank you very much. I'm sorry.
Thank you,
Thank you, sir.
Very impressive. Our next speakers are Sanjay Arana and Stefano Priano from Parsons.
Thank you, Mr. Chairman. Good evening, ladies and gentlemen. Good evening. This is the only your chance to speak because there are no question and answer in the sessions in this conference. All right. So very good evening to you. And I'll start with this on a brief note that this is actually not an industry presentation. This is not a corporate presentation. This is a technology presentation. This presentation is about the technology of geophysics, which has a huge potential to solve so many problems for the dam industry, which is extremely underutilized at present. And we hope that with this presentation, we will be able to take forward the cause of utilization of geophysics. So as this particular slide shows, why shoot blindfolded? Most of the work which we are trying to do, be it rehabilitation or trying to understand what's going inside, we are making it based on either the visual inspection or very limited data which we have. Whereas we have the tools to actually practically look inside the dam, and that's what we are going to talk about. Very briefly about the company, we are a geophysical company, and dam safety hardly constitutes 5% of our activity. So standing here, it's not a company promotion, it's more about our passion for the technology of dam geophysics that we are here. And we have offices in Delhi, Bhopal, Kolkata, and Bahrain and Saudi Arabia. And we have work experience in more than 14 countries around the world. I'm a geophysicist by profession. I passed out from University of Roorkee in 1990. That was 28 years back, which is now IIT Roorkee. Since then, I initially worked with atomic energy for some time before switching over to engineering geophysics. Now talking about geophysics, since this has really not been used much in the dam safety, very brief introduction to geophysics. I start with this slide. These are the medical images of ultrasound, of X-ray, of CT scan, of MRI. And these are the images which have been created using different kind of rays and waves to see what is happening inside our body. And these are the images created using geophysics. Again, this is a concrete dam showing the fracture zones here. This is a masonry dam showing a weak zone here, showing the density distribution within the masonry dam, clearly showing what is the density remaining in this zone after leaching has happened. This is a L section between the dam top and the dam gallery showing the weak zones within the dam body. So these sections also have been created in totally non-destructive way by using different kind of rays and waves like electrical method, seismic method, etc., to basically make an insight into the dam body. And the comparison is very valid. In terms of the time it takes, for example, X-ray takes, let's say, 20 minutes of time. A L section or cross section of a dam takes around 1 day of time. How quickly you can get information and how accurately you can get information about the entire dam body. So when we talk of dam investigation, till date, most of the dam investigations are surface, observation-based, very much dependent on inspectors. There are many dams which we have visited where inspectors have not visited the dam portions for years altogether, and there are hardly any standards for that. Whereas when we use these tools, if we look at various issues and concerns, be it for concrete dam, for earth embankment dams, or masonry dams, there are various methods which are available to address to different issues and concerns. I'll just take one by one these methods and try to show you what they are capable of. Seismic tomography is one of the very high resolution method, which basically is done between upstream or the downstream of the dam wall. So this person is on the one side of the dam putting these accelerometers. On the other side, this hammer is being struck. Basically, acoustic waves are being created on one face and recorded on the other face. These are the accelerometers mounted on the upstream face. This is the hydrophone string which is going underwater. So you don't need to empty your reservoir. It can be done even when the reservoir is full. And this is the kind of ray paths which are being generated from one side to the other. At the end of it, these are the results which we get. So this is a concrete dam. This is not from India. This is an experience in Canada. This is a good concrete. All this yellow and red which you see, this is the P-wave velocity. And this is all bad concrete, these fracture zones which you see here. This is a dam from India. You will be seeing this case study maybe presented tomorrow. This is from Chimoni. You can see from upstream and downstream, this is the bad zone. And this is the density conversion from this P-wave velocity to density. So now you actually know what is the density reduction which has happened because of leaching in this dam, which can actually help you prepare a rehabilitation plan with that much of accuracy. And you also know exactly where you need to do the correction. Another example of the shoulder section, same, the bad zone here, the bad zone, density. This is a recent experience from a dam which we did in Kerala. The same thing can be done between the dam gallery and the dam top. So this is the example from dam top, and this is the dam gallery, and the entire volume has been investigated. And the beauty is that all these investigations, one cross-section, one L-section, generally takes days. One cross-section can be finished in 1 day of time. So that's the speed at which you can do it. This is an example of another dam. The L-section has been investigated. These bad zones of low P-wave velocities have been found in this dam, and now you know where exactly the problem is, and then you can plan your cross-section and accordingly do it. So this is seismic tomography, a very strong method. There are other methods like electrical resistivity imaging. Seismic tomography was based on the strength of the material. Electrical resistivity imaging is based on the moisture content in the dam body. So here again, we are putting the electrodes on the surface. This is the picture of that. And ultimately, you know the areas in the dam body where you have higher moisture content. Higher moisture content, that means the water entry areas. And then, streaming potential can be clubbed with electrical tomography to find out exactly the zones through which the actual flow is taking place. So this is an example of a streaming potential. This is the fundamental. And so this was a bad zone through which the flow is taking place as shown by the streaming potential. There are few more bad zones here, but as of now, there is no flow taking place. But if you leave these bad zones like this, 5 years down the line, they will create flow across them. So this is like detecting cancer at the stage 1, rather than waiting for stage 4. GPR is another method, which is again used for finding out what's happening inside the dam. It's a cavity detected by using GPR. This also is used for reservoir studies. I'll be skipping part of it because it's 1 minute, 25 seconds left, so I'll not go much in detail. Idea is that there are a number of methods which practically can define physical properties of the dam without doing a drilling inside the dam, and they can be done very quickly. Now, the big question is which technique and tool to be used, and that's where expertise comes. If you use the wrong tool, you will meet the failure. And that is why it's very important to leave it to the geophysical experts to understand, because they will do it based on objective investigation, the resolution required, the depth penetration required, physical property, geometry, etc. The same methods are also used for canal seepage studies. This is one example of canal seepage study. Stilling basin concrete degradation, which we did recently in Bhutan in a project. So this was the floor of Stilling basin. 12 meters of water was there on the top, and we could see the bad zone very clearly. These are the eroded zones in the Stilling basin. So when do you need to investigate your dam? Ideally, every dam should have this investigation once it is built. For older dams, that time is now. Before designing a rehabilitation plan and after doing the rehabilitation, it's very important to understand the efficacy of the rehabilitation. And finally, the most important slide of this presentation, as far as I'm concerned, Mr. Chairman, I'll finish it in 9 seconds, recommendations. I would strongly recommend that geophysical investigations must be made an integral component of dam safety inspection program and procedures. Periodic inspections must be carried out on all large dams to detect problems at early stage. Geophysical investigation must be carried out before designing the rehabilitation program and after the rehabilitation. And these methods have great potential for other applications like canal seepage studies, Stilling basin. This is of no commercial interest to us as such, but this will do a lot of good for the dam safety industry. Thank you very much.
Thank you for a very interesting presentation. Our next speaker is Mr. Samir Vasuderva from TriStar Global. So we were going to move to the next speaker from BASF, Mr. Zahir Abbas.
Thank you. Good evening, all of you. My name is Zahir Abbas, and I represent BASF India Limited, which is a German-based conglomerate. And I'm here to introduce in very brief about my company, and then followed by what we have in offer for dam rehabilitation. I'll start with a history. BASF, typically the German name for Badisch Aniline Soda Factory, started its operation in 1865, so it's almost close to 150-year-old company now. Headquartered in Germany in a place called Ludwigshafen. Globally, 100 world's most sustainable organization, among the 100 world's most sustainable organizations. As far as the business is concerned, overall it is spread into 16 different divisions, each division pertaining to 16 different businesses. I belong to the construction chemical division that supplies solutions for the construction industry. With the total sales in 2017 of close to 4.2 lakh crore and an employee strength of more than 1 lakh, it is present in more than 100 countries across the world. This is the world's biggest chemical plant. This is the headquarters for BASF. It has around 106 kilometers of roads within its jurisdiction, and it's one of the most prestigious places for Germany as a country, well protected, and this is where the business started. It's the world's biggest chemically integrated plant. Coming now to the Indian operations, well, we are present in almost 19 locations in India with the construction chemical division with a total turnover of close to 500 crore, 450 to 500 crore, and completely supplying solutions for the construction industry. These are the local plants that we have at 5 locations in India. Yeah, almost 5 laboratories here in India to carry out the research and development activities. And then the area of expertise includes admixtures for making concrete, right from the smart dynamic concrete, which is a new concept in India, to make normal concrete highly flowable. Then we have waterproofing solutions, different industrial flooring solutions, and a very established division for repairing and protecting concrete structures. And this is where we basically address a lot of problems of dam repairs. And this is where we offer a lot of offerings for the repair of dam and rehabilitation of dam structures. Typical problems, we all know that it's, if I have to keep it in a nutshell, it's one of the biggest problems for dams is leakages, right from medium to heavy to very heavy leakages gushing out from the galleries and from the upstream towards the downstream. The challenge is how do we arrest that? And of course, there are different chemistries, there are different solutions for that. One of the other biggest problems for the dam rehabilitation, and I think, of course, you would all know that in DRIP, one of the biggest area to address at present is protecting erosion of concrete, protecting leakages from the upstream side of the masonry. And of course, we need the best of the possible solutions to ensure that. But the challenge that the Indian industry or the Indian condition faces, and this is also globally true, that there is not a single code available globally which defines the performance criteria for the correct repair needs of the dam structures or of the concrete structures as such, except for Europe, which has EN 1504, that is the only standardized code that defines the various requirements, performance requirements for the for repair and rehabilitation of concrete structures. So having said that, a complete portfolio of the repair and rehabilitation, but then I would just squeeze myself to the most common problems that today are being faced in dam rehabilitation. How do we arrest the leakages? Yeah, and the leakages arresting leakages become even more complex when they are done underwater as compared to above water. But of course, either you have the leakages coming out from the normal cracks, or these are the wide joints of the masonry through which the leakages is happening. They has to be arrested, and a material has to be produced and applied that basically stabilizes itself in underwater condition. It doesn't wash itself away, and it is able to settle in underwater conditions. So established systems of grouts, both for above water as well as for underwater repair conditions, both with respect to epoxies as well as polyurethanes that we have. This is the 2-component polyurethane grout that we have. It is capable of arresting very heavy leakages in the form of the gushing water coming out from the masonry or the concrete structures. Then one of the most widely consumed repair material in all the DRIP projects until now, as we have seen, is the repair mortars. And of course, therefore, a lot of attention goes into making these repair mortars highly stable, not in terms of just strength, but I think it's very important that they need to have a lot of shrinkage resistant, because these mortars in general fails because of shrinkage when the tension induced because of high surface area to volume ratio cracks the mortar. And this is the challenge that the mortars today faces, because all these mortars are applied in very narrow thicknesses of 25 mm, 15 mm, maximum 50 mm. And this makes the case of very large area being covered with a very small volume. The tendency for the water to evaporate in such a case is very high, apart from the fact that these mortars has to withstand the shrinkage cracking, and therefore debonding and delamination. They also has to be abrasion resistant to sustain the abrasion that is caused because of the moving water, and the silt that is carried in the water. So to address that, we have standardized the local product with the global performance. And when I say global performance, I'm referring to EN 1504, Principle 3, which defines the performance requirements for the repair motors to be used for rehabilitation purposes. And we have developed crystalline repair motors to give it even more water tightness and water packing with less permeability and highly dense, and enhanced density. So therefore, this is compliant to EN 1504. Yeah. So this is Bhavani Sagar Dam. I'll just touch upon the two projects apart from the others that we have done. Pointing remains an important work in a lot of masonry dams because that's the weakest area. So the pointing has been done, and as you can see on the right bottom, that the joints were actually weak and a lot of leakage was being observed, and how it was before and how it was after the repairs. This is for the concrete Malaprabha Dam, where the spillway has been applied, the spillway repair and the protection has been done with a stabilized mortar. And it is even more challenging because if you see the core, the top is just 25 mm or 15 mm at the max. The problem with this is you're trying to place a large volume on a small volume on a larger area. When you do so, these repair mortars tends to, of course, the water tends to evaporate, and as a result, hydration stresses develops and it cracks. Because all these mortars already have very less water content, and if you spread them on a larger volume, the small water also evaporates. So the problem that happens is shrinkage. So more than the strength characteristics, which is of course important, EN 1504 has emphasized a lot in terms of the shrinkage control, and that is exactly extremely important for the repair mortars. And therefore, it should be one of the important characteristic or the criteria to be put into the specifications so that the right systems and the durability of the repair mortars can be materialized at site. This is Malaprabha Dam. So it has a combination of both stone masonry pointing as well as the repair mortars for spillway in the form of the screed that was applied. This was a typical case where the mortars which was being used was phenomenally cracking because the thickness was crazily just 15 mm with a just water powder ratio of 0.1 or 0.11. And when this small thickness mortar was being applied, it was tremendously cracking for almost after application, every 10th hour, it was cracking. It was a big issue. So of course, there were different trials that were done, and finally, the mortar was mobilized. And of course, we were asked to do the trials, and we did trials with our products, and were able to successfully, partially complete it now because of the water levels increasing. The work is stopped, but then it will continue. Underwater repair mortars, this is extremely important because cementitious as well as epoxy, if the work has to be done below the permanent submerged level, it has to have stability. It should not wash out if it's a cementitious material. If it's an epoxy, it should settle itself and develop strength. And that's where we supply both. There's a very specialist system of FRP jacket, which is completely non-metallic and extremely bonded system, 100% watertight, abrasion-resistant system. What you see on this powerhouse is these FRP jackets has been installed mechanically, and then they're highly abrasion resistant, very much resistant to even acidic waters of 2 to 3 pH, so quite stable to the aggressive water conditions as well as abrasion. Apart from the membrane, this is very common. I mean, laying loosely held membranes which are tear resistant in a particular manner to prevent the water leakage is another, offering that we have.
Please finish.
Well, these are all the projects in TRIP that we have executed. A couple of them is already in the process. It is going on. So thank you so much. We are at stall number 29. Thank you.
Thank you.
Next presentation is by Mr. Rajesh Pandey from Messrs. Dinosaur.
Play mode, just hiding those.
Chairman. Good evening, Chairman, and all honorable guests. I am Somudi Pramanik, representing Dinosaur Concrete Treatment Private Limited. I want to thank the organizer for giving us this wonderful opportunity to present ourselves in this forum. Dinosaur Concrete Treatment Private Limited is a ISO 9001-2008 certified company and is the leading specialist in all types of underwater and above water structure assessment and evaluation works for engineering structures. Dinosaur provides expertise solution, turnkey solution for rehabilitation works, which includes inspection, investigation, survey, NDT, condition monitoring, condition assessment of structure, specialized underwater concreting works, sealing of leakages, strengthening, retrofitting, protective coating for engineering structures, mainly for dams. Experienced engineers and highly trained and capable driving teams and cutting-edge technology had helped Dinosaur to emerge as a market leader in underwater and above water services for dam structures. Incorporated in 2003, we have a reputation in the industry for our quality of services, innovative engineering solutions, and our commitment to survey, safety, and sustainability. I will play a small video, will show you more about Dinosaur, followed by few important works we have completed. Thank you.
A fast-growing firm specializing in underwater and surface repairs of civil engineering structures, Dinosaur Concrete Treatment Private Limited has been a trademark of excellence. It has developed an impeccable reputation for performing such daunting tasks with precision and efficiency ever since its inception in 2003. With state-of-the-art equipment, skilled manpower, and extensive knowledge in the field of repairs and retrofitting, waterproofing, and protection systems for engineering structures, Dinosaur provides comprehensive services for engineering structures. Dams, jetties, and buildings. Beginning with their list of underwater services, cutting-edge equipment, and trained personnel, has allowed Dinosaur to emerge as the market leader in inspection, survey, and videography in submerged environments. Their methodology involves an in-depth assessment of every flaw, post which they propose the necessary refurbishments, structural repairs, strengthening and retrofitting, waterproofing, and leakage arresting systems for dams, reservoirs, and water treatment plants are offered in both submerged and exposed conditions. Reinstatement of gate groove steel members having undergone wear and tear ensures uninterrupted operations of major hydraulic and water retaining structures. Due to repeated damage caused by seismic events, seismic retrofitting and load-bearing capacity enhancement form an integral part of their surface services. Also, devising a protection system for various structures requiring maintenance from repeated usage, deterioration, and threats from the environment, chemical fumes, and spillage is done with utmost attention. Experience and expertise are the key elements that have helped Dinosaur implement tailor-made techniques in all types of structures. For Dinosaur Concrete Treatment Private Limited, employees' safety is prime. The highest degree of significance is given to ensuring the health and security of their team, which has created an injury-free workplace. Keeping quality above all, they only provide high-quality solutions and project management services to their clients. With decades of experience, projects across various verticals, a constant desire to upgrade, and an undying passion for strengthening infrastructure, Dinosaur Concrete Treatment Private Limited is destined for success.
Thank you. Please visit on the stall number 25, please.
And now I invite Mr. CGIS, Mr. R. Stephen Herod.
Okay, good evening, everybody. Good evening. So I am Stéphane Giraud from France. I work for a group, Aegis Group. I will present it right now with a small video of 1 minute. Thank you. So it was better with a video, and now a small PowerPoint. Okay, so Aegis Group is a French engineering firm. As you've seen, 14,000 people, which make a lot of people around the world. We are working in several departments: road, aviation, rail, urban development, buildings, water, energy, major structures, and multimodal transport. We are working in 100 different countries, and actually I work in the water department. I am in charge of the dams and reservoirs. So in France, we are 300 persons working in this field, and actually we are working in the concept, design, and work supervision for the dams, as well as procurement advices like FIDIC expertise in Africa and in Asia. So in these pictures, you can see some different dams on which we worked in Algeria, in Kenya, in Mali. It is a hydropower plant, and in France, of course. So back to India. Here, we have been working for 4 years on the DRIP project with our client CWC, and we can say that these technical assistance, and this technical assistance had been funded by World Bank. Actually, June is here on the board. And CWC, everybody knows that it is based in Delhi, but it works as well with different states on DRIP program. And I've been here presenting some small presentation on the last session of this conference, and in 2016, I quoted two main issues, not issues, but the keywords, because we are actually working with a strong team in Delhi for our client, and we are around 35 person. And we can say that here it is a demonstration of first keyword is the communication. It is quite hard to understand each other in this different culture, technical culture, and as well different people from different states. And here it is a proof that we are together as coming from different international perspective. Second word, keyword is teamwork. As our client knows that all this conference and this project DRIP would not be possible if there is no team spirit, and this is quite hard to create it. It takes a lot of efforts. And I want to conclude saying that I've been working in India for the last 5 years on this DRIP project, and the third word now is time. Why time? Because with time taking steps, we can say that today, in 2018, it is the 4th conference, and we saw that it is now a real big conference, international conference, different from the first event we had 4 years ago. And it is really a pleasure to see that it is growing, and in the dam safety topics particularly. And this morning it was quoted that dams are the pyramids of the now the modern age. And to make a parallel, as if we were a family, I think that we are here today to work on the dam safety, but tomorrow it will continue to build dams with our children, and probably our grandsons and granddaughters will operate and maintain all the dams in the same spirit of today's conference. Thank you.
Thank you, Mr. Stephen. Now next presentation is by Mr. R.K. Mahana from Messrs. DHI.
Thank you. Yeah, good afternoon, everybody. Yeah, on behalf of DHI, myself, Rajesh Kumar Mahana, I am presenting you about water resource software. Actually, we are talking about like water resource structures and water resource, any obstructions. But before that, we have to understand the behavior of the water. For that, we have the answer, and we can solve it through numerical modeling. Okay. So, DHI is an independent and self-governing research and consulting organization, and it is not-for-profit organization, and it builds competence and promotes technological development relevant to the water and the environment. DHI has ongoing activities worldwide, and it has a total staff of around 1,000 plus. Okay, it has offices all around the world, and in India we have head office in Delhi. And we have several branch offices like in Chandigarh, Chennai, Assam, Patna, Gujarat, Dehradun, and Guwahati. Okay, DHI India, actually we have 3 verticals, like we have Academy for DHI training and capacity building. We have DHI software sales and client support, and we also provide consultancy. Okay, before going details about what softwares we can provide, let's talk about what water resource softwares are. You can see what different water resource, principal types of numerical models in water resources are like hydrological models, hydraulic models, river basin and planning models, hydrodynamic models, groundwater models, ecological models. So to understand the river behavior, all these numerical, you can take the help of all the numerical models. So let's give you an example. We have a physical system and which is defined by river network, floodplain structures, and generally governs by your conservation of mass and conservation of momentum, and we'll schematize it and depend by simple equivalent system and discretize as a finite difference relations and build a numerical model. The main benefit of numerical model is that you can exercise a number of scenarios, number of trials and errors, and you can finalize your project. Okay, we have we have in mic powered by DHI, we have different softwares for different purposes, like for start with like mic hydro revolve, mic 11 is a 1D channel modeling software, and mic hydro is in complete catchment modeling. Like mic flood, we have like 1D and 2D coupling modeling software from there. For urban water modeling, we have mic urban. For modeling and simulation of wastewater, we have waste, lead pack, and for coast line 2D. For mic 3, 3D modeling and coast 3, FE flow, advanced groundwater, and mic C, that is for integrated catchment hydrology. Okay, these are some of the outline of application areas for different softwares, like you can see. And I am not giving the details about different softwares, but let me give you mic hydro, which is actually the most comprehensive and proven approach to hydrodynamic and environmental modeling of rivers, canals, reservoirs, and floodplains. And it has capabilities ranging from basics to very complex modeling, while yet maintaining user-friendliness and efficiency. And flexibility and speed ensures a complete and efficient working environment. And it comes with an inbuilt auto-calibration tool and animation tools. We have different types of modules here, like hydrology, advection dispersion, water quality, and data assimilation for forecasting, dam break, structure operation, graded sediment, cohesive sediment, extreme value analysis, GIS tool, etc. For mic 21C, if you see this primary focus on sediment transport and river morphology, analyzing flow pitch and flood dynamics in rivers and adjacent floodplains, reservoir sedimentation, which is a main problem these days. You can see like sediment flow. Designing protection schemes against erosion, predicting sedimentation of water intakes, outlets, locks, and harbors. Some of the outline areas of mic 21C is like you can see channel development, navigation, river training, bank erosion reservoir, forecasting, dredging, bridges. All these problems you can address through numerical modeling. Mic flood is the integration of couple mic 11 and mic 21. You can zoom coupled 1D and 2D modeling. Likewise, you can do river animation and like for dam break. For dam break scenario, you can analyze your it's not on. Okay. So you can and we have the last but not the least conclusion. We have the tools. We have the state-of-the-art tools tested, applied, and reviewed and compared, ensure sustainability and continuous support. We have the ability to tailor software to your needs. We are committed to develop a partnership with well-qualified staff and organization. So that's all from the DHI. So thank you.
Thank you, Mr. Mahana, for sticking to the time. Now, the last presentation in this session is by Mr. Madhav Nayak and Wolfgang Litz from Mrs. BMC Wasemi.
Good evening, ladies and gentlemen. My name is Wolfgang Litz. I have the pleasure to present MC Bauchemie and our activities in India, especially in the field of water constructions. Unfortunately, the time is quite short, so I will not have the time to go into details of what I've actually prepared. I will give you an overview about the company, and I will conclude our solutions for the hydrostructural constructions in a short video. MC is one of the most important players internationally in the field of construction chemicals. We are founded in 1961, still in family management and present in India since 1987. Worldwide, we are active in more than 40 countries with more than 2,500 employees. The company mainly is subdivided in four major fields. The first field is concrete industry that concerns everything in the direction of admixtures, concrete admixtures for new constructions. The second field is the infrastructure and industry, which is containing product systems of injections, repair mortars, industrial floorings, or underground sewer repairs. The buildings concern everything concerning tile glues and those kind of things, and the consumer business in the end is end-user business, mainly found in Europe. In Germany and worldwide, 10% of our employees are active in research and development. We are members of international societies for our own development and of our products and solutions. We have about 20 production facilities worldwide. Here in India, we have a production facility in Ankleshwar in Gujarat and in Goa. Our sales office in India is located in Mumbai. Now, as I said before, I would have liked to go more into details of our solutions for the water constructions, which I will be showing in the video. Anyways, I will jump to the reference overview, which we have reached in India with various repair steps and materials.
Audio Jungle.